Namaskar and welcome to my channel. In this session, I will discuss principle and application of gas chromatography. You will be able to answer questions like what is the principle of GC? What are the different components of GC like carrier gas, column, detector, injector? What are the different chromatographic terms like R, T, and N? Which types of molecules are analyzed on GC? What are the industrial application of GC? GC is a separation technique for separation of organic volatile components. In GC, organic volatile component interact with a stationary phase as well as mobile phase. Due to difference in interaction, these components get separated. Interaction depend upon the boiling point of each component, and it also depends upon the polarity of molecule as well as polarity of stationary phase. In GC, mobile phase is gas and which is called carrier gas. Generally, nitrogen and helium are used as a carrier gas since these gases are inert. Stationary phase may be solid or may be immobilized liquid. When stationary phase is solid, it is called gas solid chromatography or GAC. When stationary phase is immobilized liquid, then it is called gas liquid chromatography or GLC. In GC, two types of columns are used, packed column and capillary column. Packed column gives theoretical plate only 1000 to 2000, whereas capillary column gives theoretical plate 10,000 to more than 1 lakh. Length of the capillary column is 10 meter to 100 meter, whereas length of the packed column is 1 meter to 7 meter. Packed column gives broad peak, whereas capillary column gives very sharp peak. That is the reason now only capillary columns are used for the analysis. Packed columns are not used. Column is the heart of the GC system, and in column separation of different components of the molecule take place. Separation is governed by like dissolve like, means for separation of polar molecules, polar columns are used, and for separation of non-polar molecules, non-polar columns are used. Capillary column is hollow from inside, and its inner wall is coated with stationary phase, and it is made of fused silica. Non-polar, intermediate polar, and polar stationary phases are used for GC analysis. Non-polar stationary phases are used for analysis of non-polar molecules. Intermediate polar stationary phases are used for analysis of mid-polar molecules. Polar stationary phases are used for analysis of polar molecules. Nitrogen and helium gases are used as carrier gas because these gases are inert. If analysis is performed on FID detector, then hydrogen and air gases are also used for analysis. Function of flow control to manage the flow. In injection port, injector inject the sample. It is at high temperature and it converts the liquid sample into its vapor form, and that vapor forms goes in column, and each component of samples gets separated in the column, and it goes to detector. Detector convert that component, means eluted component, into signal and send that signal to data processor. Data processor convert that signal into peak. Flame ionization, detector thermal conductivity detector, electron capture detector, mass spectroscopic detector are used for GC analysis. But in most of the cases, flame ionization detector is used for analysis because most of the organic molecules contain carbon and hydrogen atom. Let us understand separation mechanism by injecting sample mixture containing butanol, pentanol, and hexanol using a stationary phase which is intermediate polar. When sample will be injected, the position of sample will be at the beginning of the GC column. A stationary phase of GC column will try to attract and retain each component of the sample mixture, whereas carrier gas will try to carry each component of sample mixture along with it. The amount of interaction depend upon boiling point of each component as well as polarity of each component and polarity of stationary phase. Component having less boiling point will move faster than component having high boiling point. In case of butanol, pentanol and heptanol, boiling point is increasing from butanol to pentanol to hexanol. Definitely butanol will move faster than pentanol and pentanol will move faster than hexanol. In condition 2, each component is getting separated. In condition 3, butanol is getting eluted. In condition 3, all the components are getting eluted and this is the elution pattern. This is the peak due to butanol. This is the peak due to pentanol and this is the peak due to heptanol. Column efficiency shows narrowness of the peak and it is calculated by this formula. Resolution shows separation between the two peaks and it is calculated by this formula. Different methods of calculations are area normalization method, external standard method, and internal standard method. In area normalization method, area of a component is divided by total area of each component and it is multiplied into 100. In external standard method, standard of corresponding component used for analysis and value of component is calculated using this formula. Internal standard method is similar to external standard method. In this method, an internal standard solution is added both in standard solution and in sample solution in same amount. Value of a component is calculated using this formula. Compounds like steroids, carbohydrates, amino acid, antibiotics, and phenols having high melting point and they are highly polar molecules. They cannot be analyzed on GC to make it less polar and more volatile. Silylation is being performed and after that silylated products are analyzed on GC. These are commonly used silylating reagents. Compounds like ester, ether, amide having very high melting point and hence they cannot be analyzed on GC. They can be analyzed on HPLC or other techniques. GC is widely used in pharmaceutical industries, in food industries, in pesticide industries, in petrochemical industries for both qualitative and quantitative analysis. Identification is one of the qualitative tests. In this test, RT of A known sample mixture is compared with the standard mixture component RT to identify the component. Now question comes, if some unknown peak is there, how it can be identified? To know the answer of same, please watch my upcoming video which will be on GCMS. For any question related to this lecture, write in the comment section and I will answer on priority basis. Subscribe to my channel. Thank you.